We're going to finish up chapter 12. And last time we talked about the sun, stars, the star life cycle, and now we're going to talk about how these things start to fit together. So, our sun and our planets are part of a galaxy. You probably know the name of the galaxy, and we're going to talk about it. But the galaxy is the basic unit of the universe, meaning the universe as a whole is made up of a bunch of different galaxies. So there are billions and billions of gravitationally bound stars like our own. There are planets that travel around these stars just like our own. Whether or not they are hospitable for life is a whole nother thing. But even then, our galaxies are part of a larger scale, which is that our galaxies exist in clusters, superclusters, and there's billions and billions of galaxies within our universe. This is very complicated. Now, our solar system is part of the Milky Way, and sometimes, depending on where you are, you can see the bands of the Milky Way, but you have to be in a pretty remote area with not a lot of artificial light. It can't be very polluted in the air, but if you are able to see it, it kind of looks like this, and those are the outer bands. So the structure of our galaxy is that it's called it has a galactic nucleus, which is this core right here, and it's a rotating disk. And so you can see here that these arms are kind of leading out from that nucleus. There's a spherical galactic halo, which is hard to see except for if you took this image and it's like a flat like a pancake, and you turn the pancake on its side like this. This is the nucleus. These are the outer bands. The halo is everything that's going to exist above and below it. So the image on the left is kind of a bird's eye view. And so above where the bird would be, that's where the halo is. And within the halo, there's about 150 globular clusters of different universal matter. The majority of our, the parts of our Milky Way are going to be found along these bands. And so if you see here, the location of our sun is kind of on the outer side, not too far out, but definitely not so close to the strong gravitational pull inside. We're kind of within a band, but not so far within a band. We're going to have an entire lab about the privileged planet and learn about the real beauty of our location within our galaxy and how that permits us to see a lot of things that would not be viewable in other places. So like we said earlier, the Milky Way, the outer bands, are visible as a diffuse band on a very dark night. You can see here that within this band, this is where there's billions of other stars, and some are bound in galactic clusters, or just kind of big groups of stars like grapes. And there are other galaxies. Let me see if I can make this image smaller so we can see. Here we go. There are other galaxies. Our nearest neighbor within the local group is Andromeda. It's still 2 million light years away, so it's really far away, but it's structurally very similar to the Milky Way, meaning it has a nucleus, and it has the same spiral nature, a halo on top and on the bottom, and it's similar-ish in size, and so that's the closest other galaxy to us that is like us. Now, like we said earlier, this would be an image, and you can see here, these are all different galaxies. Each and every individual one is its own unique galaxy, and so we are really just a small piece of a really big puzzle. We do have a classification scheme that was designed by Edwin Hubble. This is him here. You can see here he has an image of a galaxy here. He's also the same Hubble of the Hubble telescope. A lot of really big contributions to astronomy. But one of the things he did was a classification scheme about the shapes of galaxy. Now, our galaxy is called a spiral galaxy. It looks like this, and it's one of his classifications. We have elliptical, which is, instead of having the spiraled bands, it's kind of an oblong shape, and it has none of the bands like the spiral arms like you see here. And then there is kind of some different agreements. So most of the time it's elliptical, spiral, or irregular. This has barred in here, But really, most of the time, that's put within the irregular classification schemes, and this is where things that aren't elliptical and aren't spiral, they get grouped into irregular shapes. Now this is the end of chapter 12, and so you'll move on to chapter 13, which is talking about our solar system more specifically.